weather get like this track like heavy rain, and what we can do the best at that moment.
We have to land the drone.
Like
So
it will take.
in this topic we'll talk about, so those parameters related to weather we are going to cover in this module. So you
Okay.
will know what you need to do in case of what kind of weather is. Okay,
Okay.
where what you need to do. So best part is, in case you finding it difficult in flying, you should safely land your drone. That is the first thing as a responsible pilot you should do. Okay, you should trigger RTL or RTH at that point in time also. Not also try to do manual landing, but you should trigger RTL. Let the system do it on its own.
It's a automatic auto system.
Auto landing.
Auto landing. Okay.
Okay, so let's start with the weather and meteorology. So when we talk about weather and meteorology, first we think we need to understand is the atmosphere. Atmosphere is a layer of gases that envelops our planet Earth. Okay, so you can see there are different types of layers: troposphere, stratosphere, mesosphere, thermosphere, exospheres. So these are all different layers at different locations. So they are not like there is a boundary which is being shown, but not necessarily this boundary is a very exact boundary. So they will be overlapping it. Okay, so if you see, the most important layer is the troposphere, where we are actually breathing and laying, staying. So troposphere is the location in which starts from the zero, that is the ground zero, till 12 to 18 kilometers. Okay, so almost 18,000 meters, in which your hot air balloons, your civil airlines, commercial aeroplanes, all they fly is in troposphere. Okay, this is the most important region of the atmosphere, where the temperature will be minimum 15 degree to maximum minus 56 degrees. Okay, so it will, as you climb higher and higher, the temperature will reduce. It will become more and more colder. Okay, so as you see, from ground it could be 15 degree, maximum it can go up to minus 56. Okay, so every temperature will keep on reducing. But if you go to stratosphere, okay, stratosphere starts from 15 or 11 kilometers to 50 kilometers. Okay, in that region the temperature will vary from minus 56 to minus 2. So there will be variation, little bit hot, cold, kind of thing. But still, even it is in minus, it is a cold only. Okay, then you see mesosphere. Mesosphere starts with 50 kilometers to almost 80 kilometers, 90 kilometers. Okay, so this is little bit or probably again this is a cooler region. Okay, minus 2.5 to 80, minus 86.5. But as you go up above the mesosphere, there is a region called thermosphere. By the name itself, you can understand thermosphere. Here the temperature will vary. Okay, the temperature will go on a higher side because you are exposed to the sunlight. Okay, so there this is little bit hotter compared to the below layers. Okay, so this is the region where you will see auroras and all this. And beyond thermosphere, there is something called exosphere, in which actually your satellites or your spacecraft, all those important satellite communications, whatever we use, they are actually flying or orbiting in this area. Okay, the exosphere. Okay, from our perspective of aviation, most important layer is the troposphere. Okay, troposphere is the layer in which actually your balloons, your civil airlines, fixed wing airlines, or aeroplanes, or even drones, different types of drones are being flown in troposphere only. Now if you see in troposphere, the earth atmosphere varies vertically and horizontally in parameters. There are 4 parameters which varies vertically and horizontally. That is, one is pressure, temperature, humidity and density. So remember, these 4 parameters will vary in troposphere depending upon location to location, region to region. Okay, so the pressure probably you can see the pressure at the sea level will be high. As you climb up, the pressure will be low. Okay, or even the temperature near the sea level will be more. As you climb at the higher altitudes, like for example you are at Mumbai, so temperature would be little bit on higher. But if you go to Lonavala, or you go to Mahabaleshwar, or you go to Uti, Kodaikanal, Simla, those locations, they are higher altitudes. So there your temperature will be low. Same thing goes for humidity also. Like we feel lot of humidity in Mumbai region, but as you go to Lonavala or interiors of Maharashtra or any other location away from the sea, so your humidity will reduce. Okay, there will be a dry heat, not a humid kind of so where we will feel humidity, and we'll feel uneasy staying in this kind of locations. Again, the density also will differ from region to region depending upon the location and altitude. So these are the four parameters, that is pressure, temperature, humidity and density, which will vary vertically as well as horizontally. So even from one location, like whatever pressure, temperature, humidity, density you feel in Mumbai, it not necessary it will be same in Pune, not necessary it will be same in Nasik, not necessary it will be same in Nagpur. So again, region to region, this will vary, okay, depending upon the elevation as well as the condition in that area of the atmosphere. Okay, every time it will be different. Like tomorrow, when you start early morning tomorrow at 5 p.m., 5 a.m. or 6 a.m. Okay, and when you reach Igatpuri, you will completely feel the difference. You are feeling hot, whereas when you reach Igatpuri Vaitarna Dam, you will feel completely cold. The night will be the coldest part over there. Okay, you will feel that you are in a winter season over there, like that. Okay, so that difference you will find. Though you are in summer, you will feel much pleasant temperature, pressure, humidity, density at that location compared to what you feel in Mumbai location. Okay, so weather is the state of atmosphere describing, for the example, degree to which it is hot or cold. So normally if you see now, today it is a very, yesterday it was little bit gloomy climate, but today I think the climate is little bit hot and clear. Okay, I can see outside the window, I can see the sunlight, I can see the other location, I can see far. I mean the visibility is much clearer compared to what I was seeing yesterday. However, even though we have been studying weather for almost now last 200 years, 200 plus years, there are weather stations across the world which are more than 200 years old. Okay, though we have been studying weather for such a long period, still that is one thing which we do not have a control. So weather is the one factor in modern aviation over which man has no control. Okay, you cannot control the weather. Okay, weather will behave on its own depending upon the situation. Okay, all of a sudden it will become cloudy. Like today early morning, I think somewhere around 3 a.m. or 4 p.m. it was raining very heavily, very heavily. I thought what would happen. Okay, but it was just a small drizzle. Okay, even some time back also, before start of our class, I saw that there was little bit drizzle was happening, but now it is very clear sunny. Okay, then I checked on the website also, on the weather website of the Indian government, IMD. Okay, meteorological department. I saw that it is a very clear climate. Okay, there is nothing. There could be a possibly a small drizzle here and there, but the climate as of now is good. I hope that our flying will happen very good for us. Okay, so we will not be affected much with the weather. Let's keep the fingers crossed, because even last time we had a similar situation, but we did really a good flying and we completed our sessions on time during that location. Only thing is that instead of 9 o'clock, we have to start little bit early. That is, we started our session between 8 to 11. Okay, so after 11 we have done our breakfast. So we skipped the breakfast, early morning breakfast, and we did the flying, and after flying we did the breakfast. So like that we did. Even the evening sessions were good. We started around 5 p.m. till 7 p.m. we were flying the drone. So we flown the drone as per our requirements and our schedule. We were able to complete our flying. Okay, but again, since that is what we are saying, weather is one factor in which modern aviation, over which man has no control. So even prior to that, there was one session where we were not able to conduct the evening session, because in the evening around 4 o'clock it started raining. So it almost rained for 2 hours. Okay, so that point in time we could not even, we tried to see that if we can fly after 6-7 p.m. At least for half an hour, but then the ground was completely wet and it was filled with the water. So we were unable to take our drone to the ground and do the flying. So the next day we actually did the flying again. We did little bit longer. We started little bit early also, and we completed our sessions as per our requirements. So we have to be little bit flexible at that point in time because of the current situation in the weather. I mean nobody is expecting such kind of a weather in summer, like you are having so much rains. I was seeing the news also, like lot of dams are already filled with 100% of water. So that much rain has happened in last almost 10 days. Okay, 10 to 15 days it is raining. and in especially in the interiors of Maharashtra, it is raining very heavily. Okay, like even in Igatpuri, Nasik, Nagpur, Aurangabad, Beed location, these locations it is raining heavily. Okay, and almost most of the dams are being filled with the water, almost like 80%, 90%. Even some dams are 100% they are filled. Like in Beed region, there are dams which have been already filled with 100% of the capacity. Okay, so they are already covered with their years of quota what is required for them. So meteorology is a branch of atmospheric science which includes atmospheric chemistry as well as atmospheric physics, which is a major focus on weather forecasting. To understand the meteorological hazards, their effects on the aircraft, and how to minimize the risk posed by those hazards. So like for example, turbulence is there, wind is there, lightning is there, all these factors will, icing is there, cold. So cold will have its own effect, hot will have its own effect, rain will have its own effect, lightning will have its own effect. Similarly, turbulence will have its own effect on the aircraft. So depending upon different types of hazards, we need to understand what risk do we have and how we can minimize or how we can avoid. So for example, if I'm flying from Mumbai to Delhi, as I told yesterday that we have to prepare a flight plan. So in flight plan, we are supposed to study the meteorological situations. We need to understand what is the weather currently and what is the forecast given for next 4 hours, 6 hours or 8 hours. That is what we need to see, and based on that we need to have an emergency plan, or we have to have some plan B, so that in case of we encounter any hazardous weather or challenging weather for flying, we should have a corrective options for that. Okay, of course ATC will be there along with us, who will be guiding, and they will be knowing more about the weather and all these things, because they are continuously monitoring the weather for safely operations of the aircraft. So ATC is the best source to take the help also, but as a responsible pilot, your job is also to make sure that you study the weather properly and have a plan, because you are actually flying the aircraft, you are taking the people along with you. So safety of the aircraft and safety of the people is your paramount importance for you. Okay, so you have to also take care of those locations. So to identify weather information that is required for each flights to interpret actual and forecast weather condition for documentation provided. To analyze and evaluate weather information before flight and in flight. So before your flight is been commenced, you need to analyze the and evaluate the weather information. So how do you get that information? So we'll see in the coming slide. A knowledge of meteorology will at least enable the aviator to anticipate some of the difficulties which weather can cause or may cause. So you should able to analyze, you should able to evaluate, you should able to anticipate what could go wrong. For example, when I am seeing most of the time when I am flying from Mumbai to Delhi, okay, I am taking this example because Mumbai is a different climate, Ahmedabad is a different climate, Rajasthan is different climate, and your Delhi region is again a different type of climate. So if you see when we are flying from Mumbai to Delhi, you will see different part of the climate. Okay, so especially when I am flying over Mumbai to Delhi, and when we reach Rajasthan, okay, especially the Jaipur and those locations, I will always see there is a turbulence because hot air and cold air is mixing. Okay, there is a difference in pressure. All that will affect, and then you will see a lot of turbulence. You will encounter a lot of time, especially in the evening flight or in the early morning flights, when the before the sunrise or before the sunset. Okay, that point in time, you will always see there is a difference in weather at that location. Probably you will sometimes encounter turbulence also over there. So that's how you should anticipate what kind of climate you can face at the particular location. Okay, so let's see now how do we find the details about the weather. So METAR is the report. Okay, METAR nothing is but meteorological aerodrome report. So every airport will have its METAR report. Okay, so it will forecast, tell about the current condition about the atmosphere over there, and it will give you the forecast for next 4 hours, 6 hours or 8 hours, whatever it is. Okay, some airport gives it every 4 hours, some airport gives every 6 hours, some airport gives every 8 hours. Even there are some very busy airport may give METAR report every 4 hours or 2 hours also, depending upon the functionality they have for monitoring the weather at their airports or aerodromes. So METAR is nothing but meteorological aerodrome report. It gives us the required data such as wind direction, wind speed, temperature, humidity, elevation. So all the information related to weather is provided into the METAR report, and it is needed for safe flying. So earlier METAR was not a report. Actually, it is like your SMS. Okay, so pilot normally used to get information in a very specific wordings. Okay, but nowadays because of the enhancement of technology available of the websites and all that things, you normally get the METAR on the website itself. So drone operation, we need to cross check the METAR for safe and secure operation where we don't risk the drone. Okay, so I am just stopping here the presentation because I want to show you the METAR sites. Okay, I hope you are able to see my browser. You just type METAR and you type Mumbai. Okay, you will see something that's all METSAT. Okay, so this is the website where you can find the METAR related information. So this is for Mumbai Airport, Chhatrapati Shivaji International Airport. You can see Mumbai, India. Okay, you can see the latitude of the location of the airport, that is 19 degree, as I told you yesterday. Longitude is 72 degree, and elevation is 8 meters. So from the mean sea level, the elevation of Chhatrapati Shivaji International Airport is 8 meters. I hope yesterday in the example I have taken this same word numbers, right? So I told you that Mumbai Airport is at 8 meters elevation from the mean sea level. This report was made 39 minutes ago. That means almost 40 minutes ago it was released. Okay, so currently if you see the UTC, I gave you one question also on this topic also, right? We are always using UTC time in the aviation. Okay, so now right now as per the UTC time is 5 a.m. Okay, 5. So currently the wind speed at the Mumbai International Airport is 7 knots. Okay, it is west southwest with gust of 17 knots. So somewhere there you can see gust. So what is gust? We will see this also gust. Okay, so sometimes gust goes up to 17 knots, whereas normal wind speed is 7 knots. Temperature currently at the airport is 31 degree. Humidity is 71%. Okay, pressure is very standard pressure, 106 hectopascal. Okay, visibility is 3000 meters. That means as far as 3 kilometers I can see. Okay, so normal visibility is 3000 meters, that is 3 kilometers. Few clouds at height of 2000 feet, few clouds at height of 2500 feet, towering, that means cumulus. Okay, cumulus type of clouds are there. So we'll see this type of clouds also. There's a slides on types of clouds. Scattered clouds at height of 10,000 feet. So you will see different location, different types of clouds. So few clouds at 2000, few clouds at 2500, and then at very high clouds, high, that is 10,000 feet, you can see scattered clouds. Okay, currently the climate looks not very clear, it is hazy. Okay, so it is haze, so it is saying haze. So this is a METAR report. Earlier the METAR report used to come in this format. See here, you can see here, I'll paste this in the chat also for your reference. I will share you the METAR reading table also, like how to read these. Like first is the station timings. Okay, then you have your wind. Okay, visibility 3000. Then few clouds at 2000, few clouds at 20,000, scattered clouds at 10,000. Okay, then temperature is 31. 25 was what? What is 25? Okay, so 25 may be the low temperature. Then your pressure 1006, but no significant. There is no very any visible any worrying matter in the current weather conditions. Okay, so it's a okay weather, not really good, not very bad. And then you see on the left side, sorry, on the right side. Okay, as per the time, that is 11:09, that is UTC. They have made a forecast. So forecast is for next some time, right? The forecast is valid. See, valid for 3 hours. Okay, at 3. Okay, wind is 7 knots. It could be the same. Visibility is not going to change. Again, scattered clouds. So this is forecast. Little rain, showers. Okay, drizzle. I told you, right, in the morning, drizzle. There could be a possibility. All of a sudden, it may rain for 5-10 minutes, just like that. Okay, temporary. Again, there could be. So this is based on the historical data what they have for last 10-20 years for the particular day. Okay, and they will see for last 7-8 days, and they will see what was the weather at the similar time last year, last to last year. Like that, they will have historical data to reference for last 10-20 years. They will refer, and based on that data, they will make this forecast. Okay, so this is how you get the METEOR. So if you see the forecast for METEOR also is there. So it will normally, earlier the METEOR used to get, the pilot used to get information about the weather in this format. So they have to interpret from this. Okay, but now because of the technology, it is very easy, very simple to understand. Okay, now let's see about METEOR for Surat. Okay, now Surat has little bit a better way of presenting. Okay, you see here. Okay, same information would be there. See, 33-degree temperature, 17 knots, 6 kilometers. See, the visibility in Surat is much better compared to Mumbai. Mumbai was 3 kilometers. Here it is 6 kilometers. There is hardly any clouds. Okay, pressure is also very standard. Okay, not much to worry. Okay, so you can see here. Okay, temperature, if you see here, 33 degree. Okay, humidity is 63%. Okay, so this is again a different way of presenting. So Surat airport is basically providing you METEOR information in this format. Okay, so there are apps also available for you to get the information about it. Let's see now for Delhi. Okay, so now if you see Indira Gandhi International Airport, New Delhi, the latitude is 28, okay, and 77 longitude. See the elevation of the Delhi airport with respect to the mean sea level. Mumbai was 8 meters, whereas Delhi is 220 meters. Okay, report was made 15 minutes ago. Wind is flowing at 4 knots, so there is a less wind flowing. Temperature is 32 degree, but humidity is very less compared to Mumbai. So Mumbai humidity was 71%. That's why we feel very hot and sweating. We do sweat. We have feel the sweating. Whereas humidity here is just 41%. So there will be a hot, but it will be a dry weather. Okay. Pressure is again standard. Visibility is very good over here. 5,000 meters. That means 5 kilometers. Okay. If you see how the METEOR is being given for the same information, it is like this. Okay. So you can see here. This is for Delhi. Okay. I'll copy this also for your reference, so you can compare, and I will also give you the information how to read the METEOR. Okay, for your reference. This is for your reference, not for the exam, or not required too much for the drones. Okay, but this is just for your knowledge to know about it, how to read this METEOR. In case you need any point in time you receive a METEOR information from anybody with this type of information. Okay. So in the chat, I have already given you the METEOR reading specifications also for your reference. Okay. So any questions so far on the METEOR? You can always check for, let's say, Nasik. Okay, since we are going to fly near Nasik region, let's check the METEOR for Nasik. Okay. So if you see for Nasik, currently Nasik is 30 degrees temperature, scattered clouds, 13 knots. The wind is flying a little bit high. Okay, 13 knots. But still visibility is good, 6 kilometers. Temperature, pressure is standard. Hardly you can see high clouds. Low-lying clouds are there. Scattered clouds are there. You can see at 3000 with respect to the elevation, you can see scattered clouds. So they are scattered clouds. Okay. Whereas you see here, Here also there are scattered clouds at 3000 at Surat. So basically, if you see Surat and Nasik is almost at the same what we say latitude, little bit up and down. Okay, not much difference is there. Okay, temperature is showing how much? 30 degree. Humidity is 59%. So not much worrying part or the weather at Nasik as of now. Okay, so not worry about it. So we can always refer these sites or this location, this information to check the weather over here. There are lot of apps available which can help you to understand the weather. You can, iPhone has inbuilt weather app. You can have even Android has its own weather apps available. You can use any third-party weather also apps for knowing more about the weather conditions. Okay. So Meta, there are several mobile apps that provide real-time metadata. Some of them are mentioned below, like UV forecast, good to fly, Dronecast, Drone Buddy, Air Data UV, Windy. I have been using Windy earlier during my initial days of learning. So I used to use Windy. It's a subscription-based app where you can. But nowadays, since on iPhone you have a better weather app also, so now I'm using what is available on the mobile itself. Okay, inbuilt. So now if you see about the weather, the first important parameters out of the four parameters, that is a pressure, temperature, humidity and density. The pressure is more important to understand about it. So international standard atmosphere is a static atmospheric model of how the pressure, temperature, density and viscosity of atmosphere change over wide range of altitudes and elevations. So international ICAO has released a document which actually tells at any given point in time what could be a standard, okay, a standard setting or standard table is there which has been released by ICAO to give a reference to understand that at particular location what could be the pressure, temperature, density and viscosity. Based on the historical data, they have created a table. Okay, so it has been established to provide a common reference for temperature, pressure and consists of tables of values at various altitudes plus some formulas by which those are derived. So there is a ICAO document which talks about the international standards. Let's see what are the international standards with respect to the international standard atmospheric settings. What are the standards defined it? Okay, so ICAO has published their standard atmosphere. So at MSL, that is a mean sea level, the temperature will be always 15 degrees Celsius. Mean sea level pressure, this is standard settings. Okay, these are the standard setting considered at the mean sea level. Okay, so at the mean sea level, the temperature they will consider as plus 15 degrees Celsius. At mean sea level, the standard pressure would be 1013.25 hectopascal. Mean sea level density would be 1125 grams per cubic meter. And the last important point, a lapse rate, that is 1.98 degrees Celsius every 1000 feet. That means up to 11,000 meters or 11 kilometers. Okay, so if you see currently the Mumbai is showing 31 degree. Okay, Mumbai was showing 31 degree. So Mumbai is at, let's say, at a mean sea level. Mumbai you can consider at a mean sea level. If you go 1000 feet higher, okay, like for example, let's assume Lonavala is 1000 feet higher. So the temperature will be there what? Can you guess? Can you guess what could be the temperature at 1000 feet? No? So if you see here, the lapse rate is 1.98 degree. Roughly you can, for a practical, we use lapse rate as 2 degree every 1000 feet. Okay, so you are going up, that means your temperature will reduce. So from 31 degree, the temperature at Lonavala may be at 29 degree. Okay, the more 1000 feet, let's say you go to Mahabaleshwar is, let's say, 2000 feet. So another 2 degrees. So 29 minus 2. So it will be 27 degrees. So you will feel colder, right? That is the reason why we go to hill stations. We enjoy the weather at hill station because it is colder compared to our city. Okay, or the lower latitudes, lower altitudes. Okay, so more higher altitude, like if you see Kodaikanal or Uti, they are 8,000 feet. So that means almost 8 into 2, 16. So 31 minus 16, it will be how much? It will be roughly around 14-15 degree. So you will feel colder, very, very cold at those locations. If you go even today, right now at this point in time at Kodaikanal Uti, you will feel like you are in winter. In the night, you have to take shawls, you have to take the blanket and sleep. Without that, you cannot stay there. Or okay, you have to drink hot water in Kodaikanal. Even in the restaurant, they serve you hot water at Kodaikanal. I mean, if you have gone any point, not gone, that's a different thing. But anybody who would have gone, they would be aware of these things, right? So that is what is different. Even you go to Simla, okay, this is a high altitude location. So your temperature will reduce as you climb up. So the lapse rates, the standard lapse rate is 2 degree every 1,000 feet up to 11 kilometers. That is in our troposphere. So as you climb above up in the troposphere, the temperature will get reduced. It will become colder, colder, colder. That's why most of the time when you are flying, when a pilot is making announcement that we are flying at 30,000 feet, and the my outside temperature he will sometimes tell in minus, okay, so minus 38 degree or something like that he will say. So it is a freezing cold temperature outside the aircraft, whereas you will not feel that temperature within the aircraft because your cabin is pressurized cabin, okay, you will not feel. That's why you are not supposed to expose to the external atmosphere at that high speed. Recently one of the fighter pilot was awarded a award last couple of days back. Do you know the name of that pilot? Gallantry award was given to him. Have you seen that current award ceremony? Okay, so he was flying at 30,000 feet, and the canopy got opened up and flown out. Okay, so he was flying without any protection. So in that scenario, possibility of that he would have died, but he used his airman craft ship, okay, and he safely landed the aircraft, okay, by using the best skills what he had that point in time. So I think his name was, I forgot his name. Okay, I will share you on the chat. Okay, so he was recently awarded because at 30,000 feet, it is very impossible to stay alive for a longer period. And then in that scenario, he actually successfully brought from 30,000 to 10,000, and then he safely landed the aircraft without the glass covering on his spacecraft or the jet aircraft. Okay, so let's see types of pressure. Yesterday we have seen on this topic. I have shared you the image also for your easy understanding. So in aviation community, the term QNE, QNH and QFE are used to describe the standard pressure, local altimeter and field elevation respectively. So QFE is the field elevation. I told you yesterday, from a drone perspective, we have to refer always QFE with respect to the drone. When the drone is on the ground, the QFE will give you reading as 0 degree. Okay, so QFE is the altimeter pressure setting at takeoff location which indicates the height. So on the ground, the height of your drone will be 0. As it takeoffs, it will start rising. So 1 meter, 2 meter, 10 meters, 20 meters, like that it will rise. Okay, QNH is a nautical height. So QNH is the altimeter pressure setting at the takeoff location reduced to MSL. Okay, so reduced to MSL. That means if you see your QNH at Mumbai airport, if the drone is on the ground, the QNH will show how much? Can you tell me? I told you the airport is at 8 meters. No?
Sir, it's 8 meter.
Correct. So at the ground, it will be 8 meters. Okay. So QNH will be 8 meter, QFE will be 0. Okay. So when we are referring to QNH, it will reduce to MSL under ISA condition which indicates the altitude. Okay. So with respect to the mean sea level, You are telling the altitude of your ground, though telling the altitude of your drone with respect to the mean sea level. Though your drone is at the ground, still the QNH will show you, if you are setting altimeter at QNH, it will show you 8 meters. Okay, at its climb 20 meters high, so 8 plus 20, so it will show you 28 meters. But if you set your altimeter to QFE, it will show you 20 meters. Okay, whereas QNE is a altimeter pressure setting at the standard atmospheric pressure, that is 1013 hectopascal, which indicates the flight level. So QNE is normally set at the sea, in the sea, in between the sea, where you do not have any reference point, you do not have a mean sea level, or you do not have a terrain to refer. Okay, so there you are taking a reference of your altitude with respect to the atmosphere. So the barometer will actually measure the difference in the pressure. Okay, so at the ground the pressure is, or at the base, the pressure at the standard sea level pressure is 1013.25 hectopascal. So as it goes, the pressure will reduce. So automatically, as the pressure reduce, it knows at what level pressure, what level it would be there. Okay, so accordingly that will convert based on the pressure. It will convert your altitude. So that is the reference point as a flight level. Okay. Any questions here on QFE, QNH, QNE? So from a drone perspective, always remember QFE, okay, the field elevation, because we are always flying drone on terrain areas. Okay, we are not, as of now, we are not flying any drone in sea. Okay, until unless there is a requirement and your drone is equipped to fly in a sea. Okay, because there is where we need to measure. So a lot of time drones are not equipped, so drone doesn't understand the height. So normally drone gets crash in the water. Okay, a lot of time the drone will get crash in the water. Okay. So again, the same diagram what we discussed yesterday, you can see QFE here, the height, the elevation of the airport with respect to the mean sea level. So if you see mean sea level, QNH is with respect to the mean sea level, it will talk about altitude. Okay, whereas QNE, okay, will talk about the flight level with respect to the standard atmospheric pressure, that is 1013.25 hectopascal. So if you see here, QNH is nothing but QFE plus elevation. Okay, so when we are talking about QNH, it is QFE plus elevation. Okay, that is how you should understand the pressure settings, and which gives you the altitude or height of a respective flight at the with the respective location. Okay, if it is terrain, we refer to QFE. If it is we are nearing to the sea level, we'll talk about QNH. In the middle of the sea, we'll always talk with respect to the flight level. From a drone perspective, we are only interested in QFE. So every time we see on the our remote control also, when the drone is at ground, it will show you 0 meters or 0 feet. Okay, as it climbs, when you give a throttle, it will go. So normally at 4 meters, okay, 4 meters will actually fly our drone, which is a very good visible height for us to fly. So when you are flying on day 4, you have to, it's a job of a co-pilot as well as a pilot to see that their drone is safe at around 3.8 to 4 meters of height. Okay, so you have to fly your drone at 4 meters, little bit 4 meters, around 4 meters of height. Okay, so it is very good height, very safe height, where your drone, you are comfortably flying it in all directions. Okay, so remember this. I will be sometimes in between when you are flying, I will ask. So it is a responsibility of a co-pilot to answer. If the co-pilot is not answering, the pilot should answer what is the height at which the drone is flying. Okay, so after pressure, wind. Okay, so wind can be measured using a device called anemometer. Okay, it is a device that used to find the wind speed. So there are mechanical anemometers also there, and then digital anemometers are also there. So it is analog as well as digital. So analog anemometer are fixed. So normally most of the old buildings or weather stations. Do you know where do we have a weather stations in Mumbai? Are you aware where is the weather stations in Mumbai?
I think Santa Cruz.
Yes, one is in Santa Cruz.
One is in Colaba.
Correct. So we have a 2 weather stations in Mumbai. One is at Colaba and one is at Santa Cruz. So a lot of time in the news, either at the beginning of the news or end of the news, they will refer that as per the Santa Cruz weather station, this is the temperature, this is the humidity, and this is what it is. They will give you the information related to weather. Short information about it. Okay. So same thing, they either refer to Santa Cruz or they refer to Colaba. So they will always take readings from both the stations, and then they will sample it out, and then they will give the average readings out of it. Okay. So then you can always have analog fixed to the locations, but then nowadays, because of the technology, we have a digital handheld anemometer also available in market. This is available on Amazon at around, I think, 300 to 500 rupees ke cost mein. You can purchase this analog digital anemometer also. Okay, this is very tiny device, not 100% accurate, or it could be, but because it is a point in time you are measuring the speed. Okay, so wind speed should not be more than permitted, limited for manufacture at the time of drone operations. So our drone operations are advised to fly below 15 knots of wind. Okay, so if the wind is flying above 15 or more than 15 knots, you are not supposed to fly your drone. You have to land your drone. Okay, so that is what you need to take care. So depending upon your drone to drone, you have to refer your manufacturer's guidelines for that purpose. Some drones are capable of flying at little bit higher. Okay, but normally most of the drones you should fly below 15 knots, because higher the wind speed, more power is consumed and your drone will become more unstable. So beyond 15 within 15 knots is a good wind speed, or a normal wind speed what we consider to safely fly the drones. Okay, so apart from anemometer, there is another device to measure. You will see this type of windsock available lot of time on the airport, aerodromes, or even at the weather stations also. Okay, so it is a light flexible cylinder or a cone mounted of a mast to show the direction and the strength of the wind, especially at the airfield. Okay, so normally you will see a lot of even army bases, air force bases, you will see this windsock. Okay, it is a white and orange strips on the windsocks. Okay, they actually indicates the relative wind speed. So there are 5 sections. If you see, there are 5 sections: 1, 2, 3, 4, and 5. Okay, so if you see, only the first section is horizontal and remaining 4 sections are downwards. Then you are seeing that wind is flowing at 3 knots. If 2 sections are horizontal, then it is a 6 knots. If there are 3 vertical horizontal, then it is 9 knots. 4, then it will be 12. If all 5 sections are horizontal, then it is flowing 15 knots or more. Okay, so if the wind is flowing minimum at 15 or more, your windsock will be in a horizontal position. So if the windsock is this way, it will show you the direction of the wind, as well as it's telling you that your wind is either 15 knots or more. So if this type of is there, if it is more, you can feel the wind more than 15 knots. So if you're feeling, you can feel about your drone also. Your drone will start moving left, right. Okay, forward, backward positions. Okay, so it will start drifting. If you see that, either you should lower your drone or you should safely land your drone. Okay, that is what is advisable. Again, you refer your OEM documents on what wind speed it can sustain. Okay, if the wind is momentary, then it is a different thing. But if it's continuously flowing at 15 knots, like we saw Nasik Metar, it was showing 17 knots. That means wind is flowing there continuously, high speed, that is more than 15 knots. So that location, we are not supposed to fly the drones at that point in time. Okay, so we have to wait. Like last time also, when we were flying in the evening, almost for 15-20 minutes, the wind was all of a sudden was flying at a very high speed. So that point in time, we just rested the drone, we landed the drone, and we were just resting, sitting, talking about the drones and all the things. So before almost 15-20 minutes we waited, then it became normal. Then we again started flying our drone sessions. So that is how you should plan your flying sessions according to the weather. Okay, from a drone perspective, there are 2 important aspects, because see, pressure will not create, because you are not flying drone very different location. You are flying within your visual line of sight. Okay, so whatever is the current pressure, so that will be a standard pressure. Only 2 important factors which will affect your drone is, one is visibility and second is wind. And probably right now, because of the season, the rain will be affecting. So if there is rain, there is completely no for flying the drone. But 2 only important aspect is wind and the visibility you have to consider before taking a takeoff of your drone. Okay. So the first thing when you go on the field, thing you need to check is the visibility and the wind. Okay, these two things you should take a decision about flying the drone. Okay, then other parameters you need to verify, like your pre-checks, post-checks, all those things you need to perform before flying the drones. Okay, so any questions so far on the wind? So you're clear? 3 knots, 6 knots, 9 knots, 12 knots, 15 knots. So seeing at this night, a lot of time you would have seen, but you not know how to measure the wind speed. But now you can, looking at the windsock, you can tell how much wind it's flowing, right, at any given point in time. So we have a windsock. We install the windsock at our flying location whenever we are doing flying during our drone sessions. Currently, we may not put because of the rain and all the things. A lot of time, and there, especially right now, there is a heavy wind is flowing. So probably, more than 20 knots or 30 knots, the wind is flowing at that location. So in that case, it is very difficult to keep the wind, because ours is not a fixed pole. Okay, so we are just temporarily putting or mounting it when it is required. Okay, so that's why we cannot continuously have a windsock at our flying location. We are yet to put our fixed at the location. Okay, so we'll temporarily mount it on a structure just during our flying sessions, depending upon the weather conditions. Again, if the wind is flying with very high, probably we may not put the wind sock over there. Okay, then we can use our handheld anemometer, digital anemometer, to measure the wind speed. Okay, so now we talked about, when we saw the METEOR, we saw gust, right? There was a word called gust. So what is gust? Gust is a sudden increase in wind speed, often with change in direction, lasting less than 1 minute, and it is a local effect. Okay, you will feel this only locally, not necessarily 1 kilometer away from you, the person will feel the gust. So gust is only a local. Okay, it is change in direction lasting less than 1 minute. Okay, remember this definitions. Okay, lasting less than 1 minute, change in direction. Okay, with a change in direction lasting less than 1 minute is called gust. It is a local effect. Then there is a period called lull. Lull is a period without waves or wind. So that's a silence. Lot of time you will see this, right? All of a sudden the wind will flow, and all of a sudden there will be a silence, period of silence. Okay, so lull is a period without waves or wind. Okay, then let's see what is the next. Next is squall. Squall is again sudden increase in wind speed. Okay, if you see here, gust is also sudden increase in wind speed, often with change in direction, lasting less than 1 minute, and it is a local effect. Now see the squall. Squall is sudden increase in wind speed, often with the change in direction. Okay, the gust also has the same thing, but lasting 1 minute or more, and can cover a wide area. Okay, so gust is temporary and momentary, less than 1 minute, whereas squall is maybe 1 minute or more, and it will be a larger area. So you can see the squall coming. Okay, you can feel the squall from far location. The squall is really important to be predicted. Carelessness on the part of squall can result in crash of the drone and hence loss. So if you see the squall, the sudden increase in wind speed, you can see area, right? You can all of a sudden see the trees and everything moving. So you can see in the picture also how the skull looks. You will see a lot of dust, all that things coming. Okay, again, this is not for a very long period, but it is 1 minute or more. It may be for 2 minutes, 3 minutes, 4 minutes, maybe 5 minutes also. Okay, some period it will be. In that scenario, you should immediately land wherever the drone is. If possible, try to land it there itself, or trigger RTL or RTH. Okay, so you, as a safe drone pilot, you should be well versed with your RTL command. So normally when we are flying the drone, even currently in DJI, like if you see all the DJI drones, currently they have updated the software, and the current software has a feature called RTL RTH. So earlier there was no option of doing triggering direct RTL or RTH. Okay, it is only during the emergency procedure you can trigger RTL or RTH. But now they have put a separate option over there where you can trigger always RTL. So whenever you are landing a drone, you should always practice landing using RTL. Okay, so you should try to see that your drone normally lands where you are actually taken the takeoff, but it will never land at the same position. There will be always a variation. Okay, that 3 meter of variation will be always there. That is what we call as horizontal dilution of precision. Okay, when we are flying, we will be measuring, we will be always have to monitor these parameters also. That is HDOP and VDOP. Okay, so these are the two parameters also we have to monitor during our flying sessions. Before the flying as well as during the flying, we have to see what is our HDOP and VDOP continuously. Okay, and when we trigger the RTL, normally you will see it will try to be more closer to your landing locations. Okay, plus minus between 3 meters of diameter. Okay, so carelessness on the part of the skull can result in the crash of the drone and hence loss. So whenever there is a squall, you can see squall from a long far off space. Okay, so you know the squall is coming, you should always land your drone immediately. Okay, so any questions so far on the wind, gust, lull, squall, and the last two is gale and hurricanes. Okay, so gale is basically exist when the wind speed exceeds 33 knots, that is double the normal wind speed. Okay, so 15 knots normally we consider as a normal wind speed, but beyond 15 is always considered a very high and dangerous. So double the normal 15 knots is 33 knots, almost 33 knots, above 30 knots is called as gale. Okay, and 4 times the normal wind, that is 15 4s are 60, so 63 knots is what you have a hurricane. Okay, exist when speed exists 63 knots or more. So in these both scenarios, you normally should not fly your drones. Okay, I am talking about quadcopter. Okay, some drones are capable of flying in this condition because they are fixed wing. Okay, fixed wing drones normally for measuring the weather, and they do a lot of study of the wind and the atmosphere at this point in time. Okay, when there is a gale or when there is a hurricanes, to understand what is happening in that area. Okay, so they will normally fly a fixed wing, not a rotor craft, because rotor craft will not sustain in this speed. Okay, whereas fixed wing can sustain it, you can fly. Okay, but you need to be a very skillful pilot to fly the there are even manned aircraft which studies the hurricane. So they actually take the aeroplane inside the hurricane to study the hurricane also. So there are a lot of you can see online on YouTube also. There was one incident where the weather aircraft, they actually took inside the hurricane and it got stuck inside. I mean, they were not able to see what to do, but still pilot using his skill, he brought the aircraft above the hurricane and safely landed it. Okay, so that's a very good episode to see how the weather affects the flying and how it affects the instruments and all that things. Okay, so after pressure and wind, then let's see about the cloud. Cloud is a mass of a minute water droplets of any tiny crystals formed by the condensation of the water vapor in a free air at a considerable elevation. So from 2000 feet onwards, okay, even at the 1000 feet, you will see clouds. Okay, as the clouds are formed at some height over the surface of the earth, they take various shapes. So you see clouds with the different shapes. So looking at the shape, the height, the expanse, the density, and the transparency of the clouds, they are grouped into 4 types. So there are 4 types: cirrus clouds, cumulus clouds, stratus clouds, and nimbus clouds. So now, up till now, you might have been seeing the clouds, but you do not know which cloud to be called as what. But now you will able to tell. Like when you go to Igatpuri, if you see the clouds, students themselves will be tell. Like, okay, now we are seeing cirrus clouds, we are seeing cumulus clouds, we are seeing stratus clouds, or nimbus clouds. So you can take photographs of those clouds for your reference also when you are seeing it. Okay, up till now we were just seeing the clouds, but we don't know what to call them. But now, because of this session learning, we were able to tell. So now you are able to tell the wind speed, you can tell the pressure, you can tell the types of clouds. So this is what you understand once you become a pilot. So you learn about the weather over here very extensively. Okay, so there is a separate topic for the CPL students. CPL means commercial pilot license. So there is a exam, special paper is there on weather and meteorology. Okay, where they have to study a book, and the topic, it is almost, I think, how much 80 hours of education is there on the weather and meteorology. Okay, so cirrus clouds formed at the height of 8,000 to 12,000. They are thin and having feathery appearance. Okay, they are thin and having feathery appearance. They are always white in color. So you can see the picture over here. If you see this type of clouds, they are cirrus clouds. Okay, whereas at 4,000 to 7,000, so they are little bit below the cirrus. Okay, the cumulus clouds formed at 4,000 to 7,000 meters. They exist in patches. Okay, they exist in patches and can be scattered here and there. Cumulus looks like a cotton wool. So normally you will see. So currently, if you see, go outside of your house, you will see a lot of cumulus clouds are there currently. Okay, there are cumulus clouds available. Okay, they are like cotton wool. Okay, so looking at the shape and the feature or appearance, you can tell. Okay, they are feathery. Okay, white in color. Okay, they are cirrus clouds. They are at a very high altitude, 8,000 to 12,000. Whereas cumulus cloud are lower. Okay, because of the expanse, weight, and all that thing. So they are little bit lower. They are at 4,000 to 7,000. They will be like a cotton wool. Okay, cotton wool, like how cotton we see normally in the house. Similar type you will see. So these are called cumulus clouds. Okay, let's see the third type. Third type is called stratus clouds. These are layered clouds covering large area. Now, if you see these clouds, these are very small areas. You know, they are very in patches. Okay, they are not, they are scattered here and there kind of thing. Okay, but if you see the stratus cloud, they cover the large portion of the sky. Okay, they clouds are generally formed either due to loss of heat and mixing of air with the different temperatures. So normally this type of clouds you will see either in early morning or in the evening time. Okay, because there is a temperature variation is happening at that point in time. When the sun is rising or sun is setting, that time there is a difference in the temperature, lot of difference in the temperature happening that point in time. So that point in time you will see this stratus clouds. Okay, whereas the nimbus clouds are black and gray. So looking at the color itself, you will able to tell the type of cloud. So nimbus clouds are always black and gray. They form at the middle level or very near to the surface of the earth. They are extremely dense and thick, so they don't have any shape. So they are very low. So this type of nimbus clouds normally you will see during the rainy season. Okay, when it is raining very heavily, continuously raining, so it will cover the entire area. Okay, so you will not see the shape or anything. You will see completely dark, gray dark. The visibility will be very low or zero, almost less than zero. Okay, so in that scenario, it will be more or less raining, or you know, the visibility will be very low at that point in time. So nimbus clouds are black and gray, whereas stratus clouds are layered cloud covering large portion of sky. They are at little higher altitude, but they are formed due to loss of heat or mixing of air with different temperatures. Okay, so when you go out, try to see the sky and try to figure it out type of clouds whenever you get a chance. Okay, so weather impact on US operation, as I said, cloud base above 9,900 feet, or distance to the cloud would be less than 2,000 feet. It will be basically create a VLOS impact. Okay, so visual line of sight will be impacted. If visibility is less than 3 miles, again you will have a VLOS impact. Fog, cloud and precipitation, it can impact your airframe. Short circuiting of electronics, again VLOS impact would happen. If there is icing, you know, especially in the cold locations like European countries, or you're flying your drone in Kashmir, Shimla, or Ladakh kind of region, you know, there you will normally have icing. So ice will be formed on the body of the airframe. So that will cause the performance issues. It will cause instability in your drone also. Lot of time icing happen on the propeller also. In the aeroplane, normally it will form on the wings, and because of the icing effect, lot of crashes has happened worldwide. And after studying this phenomena, the commercial airlines, especially like Boeing, Airbus, they have introduced a functionality on their aeroplanes called as de-icing functionality. So whenever they pilot, normally before the takeoff, he will see whether there is a icing on the wings. If you see the ice is formed on the wings, he will immediately turn on the de-icing function. So it is nothing but it's a heater. The coils are there fixed inside the wings. Okay, so it will hit the wing, it will hit the fuselage also. Okay, during the icing. If your aircraft is not having that kind of functionality, de-icing functionality is not there, so the pilot will request the local ATC that to provide a hot water tanker. Okay, so they will spray a hot water on the fuselage and on the wings. So immediately the ice will melt and then they're good to take off. Okay, that is how normally worldwide people follow. Okay, lightning, when there is a lightning happening, okay, so a lot of time due to lightning you will see drop in communication due to radio frequency. And a lot of time you would have seen this whenever there is like recent times also when there was a rain happening in Mumbai, lot of lightning was happening at that point in time. If you are listening to a radio, even mobile communication, or even you are watching television, you are seeing an IPL match, lot of time you would have seen disturbance in the signal or lag in the signal or delay in the signal, or all sudden your receiver would have freezed for a point in time, okay, for a moment. Okay, that's because of the lightning. Okay, then wind and wind shear, loss of control, instability to return to home, mission failure, and all. A lot of time you will see all of a sudden the wind either moving up and down or left and right, a very heavy speed. So that time also you will face problems and you will normally have a challenges in flying the drones or airplanes also. Moderate or great turbulence, so reduce mission duration. So if you find a turbulent area or anything, that means either you have to avert your mission, abort your mission, or you have to change your direction or course of your direction of your flight. Okay, that's how you will fly in this condition. So these are the impacts due to weather on your UA. So as of now we are only considering unmanned aircraft systems operations, okay, and how it affects the get affected because of the weather. Okay, so if you see this picture, cloud distance visibility, you are standing somewhere here, from you, let's say 0.5 kilometers or 0.5 miles, you can see your drone very clearly. But as it moves away, okay, 1.1 miles or 1 kilometer, I say, okay, forget about the unit, you just for a reference perspective, okay, your drone will start getting little bit diminished, or it will be very difficult to see as you go further and further. So roughly 2 miles or 2 kilometers, what we consider 2 to 3 kilometers is a good area to see the drone. Again, it depends upon the size of the drone. If you are flying, let's say for example you are flying a DJI mini drone or DJI neo drone, even at 2 miles or 2 kilometers it will be very difficult to see. But if you are flying a bigger drone, like phantom drone is much bigger, okay, so you probably will able to see at least some extent. Okay, if you are flying our drone is very big, okay, compared to the DJI drones or anything. Our drone is very big in shape, okay, you can clearly see at least 2 kilometers or 2 miles, okay. But as it goes further, so basically in the normal conditions your visibility is good up to 2.5 miles, okay. Beyond 2.5 miles, normal person, a normal eyesight will not able to see the drone. So your standard visibility is up to 2 miles to 3 miles, I would say, between that range. Again, it's subject to people, person to person. Okay, so that's why you see the visibility there, it was showing 4 kilometers, 6 kilometers. So that means the visibility is good, but size matters. So things which are very far but big in size, like big buildings and all that things, you can see very far. Like even they are 6 kilometers away from your location, you can still see it. That's why you see the mountains, right? Because mountains are such a huge structure. They are so far, but still you can see. But depending on the size of the object, standard object for your visibility, like for a drone, it is 2.5 miles. Standard is 2.5 miles. So roughly we'll say 2 miles to between 2 miles to 3 miles, we can see a drone comfortably. Okay. Beyond that, it becomes very difficult to see the drone. So any questions over here on the visibility?
No, sir.
Okay. So cloud and fog both forms when the water vapor condenses or freezes to form a tiny droplets of crystal. So cloud, we've seen cloud is also the same. Fog is also same. Only difference cloud is that it is above the earth or above the surface, whereas fog will form always near to the surface. Okay. So cloud can form at many different altitudes, where fog only forms near the ground. So especially in winter or in a heavy rain time, a lot of time you will see fog. Especially in the winter, you will see a fog forming near the lake or in the valley, or you go to the higher altitude cloudy regions, you will see the fogs, right? You go to Lonavala, Mahabaleshwar, you will see something like this, a foggy area. So fog is defined as a cloud. So fog is also a cloud only, but it is very close to the base or close to the ground. Okay, that's why we call it as a fog. So fog can caused by cooling. As the air cools, it becomes denser and drains into the lower areas such as river valleys, where thick fog accumulation may occur, and this will impact your visibility. Lot of time fog is caused by evaporation also. When the cool air moves over the warm air, enough moisture may evaporate from the water surface to the produce. So normally you will see this fog, either in the evening or early morning. In the winter, you will normally see the fog in the early morning sessions, right? Because that time you're already the weather is cool and the sun is rising, so temperature difference is going to happening at that point. So you will see a lot of fog happening. But as the sun rises, like 8 a.m. or 9 a.m., you will see fog get completely disappear from the locations, right? Depending on the weather conditions. If it is completely cloudy, then you may not have clearance of the, like even 9 a.m., 10 a.m. also, like especially in Lonavala, the Tiger Valley, if you have gone to the location, you will see fog like this, even at 10 a.m., okay, or even at 11 a.m. So it depending upon the location to location, and the time and the altitude will make the difference about the fog. Okay, I talked about the icing. So freezing rain is a common ahead of the warm front in the winter. Serious icing occurs where aircraft is flying near the top of the cloud air mass beneath a deep layer of warm air. So as I told you, as we are flying at a high altitude, the outside temperature is very cold. Okay, so it is a freezing temperature. So that point in time, even also there is a lot of chances of icing happening on the wing. That's why you see these Boeing aeroplanes or Airbus aeroplanes, the current ones, okay, last 10-20 years old aeroplanes always have a de-icing functionality fitted on those aeroplanes. So the pilot, the moment they see there is icing getting formed on the aircraft, they will always on the de-icing functionality. Okay, so raindrops are much larger than the cloud droplets and therefore give a very high rate of catch. So it will affect your performance. Okay, the moment you have icing on the wings, the functionality, the way the wing is converting, the pressure difference, what is happening. So a lot of time you will see, because of the icing, your aeroplane getting descent. Okay, so it will affect the performance. So in a freezing temperature, they form a clear ice. Okay, so normally you will see a clear ice is getting formed on the wings or the airframe structures. So this is very dangerous. It can affect the performance. There has a lot of crashes has happened in past because of this icing. Okay, so that is a very dangerous part. So you need to always activate the de-icing functionality over here. As of now, drone doesn't have to worry about it because we are not flying the drones, especially the rotorcraft drones I'm talking about here. Okay, in case of like your Predator drones or those things which flies at 10,000, 20,000 flight, they would require the de-icing functionality also be available on those drones. Okay. Lightning also causes thunder, a sound from the shock waves which develop the gases in vicinity of discharge experience a sudden increase in pressure. So lightning occurs commonly during thunderstorms. So we have seen the thunderstorm recently in Mumbai. Like last week there was a good thunderstorm happening a lot of time at the night, especially in the night, as well as other energetic weather system, like especially in Thailand, Indonesia, those locations where you have a lot of volcanic areas is there. So there you can see volcanic lightning happening at that point. So people, the aeroplanes, if you're flying from, let's say from Mumbai to Australia or even from UK or those locations, who fly towards Australia, the path is over the Indonesia or Thailand area. So normally they will not go closer to the land, but they will fly over the sea. Okay, the moment they go over the land, they will see a lot of volcanic thunderstorms or the volcanic lightning happening in the air. So they will avoid that region flying. Okay, wind shear. Wind shear is nothing but sometimes referred to as wind gradient. It is a difference in the wind speed or a direction over a relative short distance in the atmosphere. So like gust or squall, okay, in the air, above the air. I'm not talking about the ground, but in the higher altitude. So you will see that is called as a wind shear. Okay, so atmospheric wind shear is normally described as either vertical or horizontal wind shear. You can see in the picture, if it is moving vertically up and down, then it is called as a vertical wind shear. If it is moving lateral, okay, then it is called as a horizontal wind shear. So horizontal wind shear is a change in wind speed with the change in lateral position for a given altitude. Whereas vertical wind spare is the change in wind speed or direction with the change in altitude. So here you can see the difference in the wind, okay, with respect to the altitude. Whereas here at the same altitude, it's only a lateral motion. Okay, so this is called horizontal wind shear. This is called as vertical wind shear. The last slide, turbulence. Yesterday, I think Prayesh asked about the turbulence. So turbulence is a sudden violent shift in airflow, causes wind, storms or jet streams. Object near the plains, particularly the mountain ranges. If you are changing altitude, like you're changing above, going above the mountain and then going back. So that's the location normally you will see, because see, if this is also a difference in the air. So a lot of time the air will be flowing, and then there will be a pressure difference will be created, okay, and this pressure difference will cause the turbulence in the air or in the atmosphere, okay, or because of the temperature differences, okay, especially I gave example of Rajasthan. So there is a cold air in the atmosphere above, but where is the ground is heated, okay, because of the sand. So that sand, the hot air will start rising and get mixed with the cold air. So at that point in time, you will normally see the difference in the pressure, which will cause the turbulence. That is the reason why we know most of the time get the turbulence when we are flying near the Jaipur or those regions, especially in the sand locations. Okay, so that is the time when we need to correct our course. Okay, so we may request ATC that we are facing a turbulence. So based on the type of turbulence, what type of turbulence? The normal light turbulence will always have an aeroplane moving up and down by 1 meter. So this is okay, manageable. You will not have much issue with this wind. This is a very normal turbulence. But if it is a moderate, okay, rise of drop of 3 to 6 meters, okay, if your aeroplane is moving little bit up and down considerably, so this point probably whatever, if you have been served with the liquid like water or anything, coffee, tea, it may get spilled, okay. So that point in time, the pilot will make announcement. The cabin crew will normally avoid and tell you to wind up the things as fast as possible. But if it is very severe, okay, like rise up and down of 30 meters, this is very difficult situation. Okay, this is normally pilot will always avoid the severe. Moment they find it is moderate, they will ask the ATC to give a corrections. Okay, so either they will give a correction like you are flying at 10,000 feet. ATC will recommend to fly above the wind turbulence area. So normally they will tell you 10,000 feet, you climb to 15,000, or maybe you climb to 18,000 feet, okay, like that, or 18,000 meters, or you may ask to descend also, or maybe you will ask vertically, lateral motions. Okay, so there you will either change your course for certain period and then again you will join back your desired path. Okay, so that is how they will say it. So light turbulence momentary causes slight change in altitude or altitude and slight bumpiness. Occupants of the aeroplane may feel a slight strain against their seat belts. Moderate turbulence is similar to the light one but somewhat more intense. There is, however, no loss of control on the airplane. But in severe conditions, okay, possibility you may lose the control of your aircraft. So that is why the pilots will always, whenever they feel that there is a moderate turbulence, they will always correct, because possibility of turbulence getting from moderate to severe is always high. So they will always avoid even the moderate turbulence and they will try to correct their course of action by in conjunction with the ATC permissions. Okay. So that's all about the weather and meteorology. So you have any questions over here, or we can take a break of 10 minutes. Let me know.
Hello.
Okay. So let's take a break of 10 minutes. We will join back at 12:15. Okay.